Now we will find the potential due to a dipole. So there are three different positions basically with respect to dipole. So what is dipole? Equal and opposite charges placed at a distance of 2a apart. So generally we will take it as 2a so that we can exactly map the center of dipole, that is a distance from minus q and from plus q it is at a distance of a away from it. Now three positions are nothing but one is on an axial line, that is through the line that is passing through negative and positive q, and another is equatorial plane, that is perpendicular to the line that is passing through the center and perpendicular to this line connecting minus q and plus q. So this is equatorial line, this is axial line. Okay, now on an axial line, let's say to find the potential at this position, we have done the potential due to a charge system, right? Now when I am bringing a unit positive charge here, what will be the net potential? It has potential with respect to plus q and with respect to minus q. Now just ignore minus q and find the potential with respect to plus q. What is that? 1 by 4 pi epsilon 0 q divided by this distance. Now I am going to take the distance where we are going to find the potential as r distance away from the center of the dipole. Now this with respect to q, this is the distance, but we know only this distance, but we also know a. Okay, the distance in between center and plus q. If this is a and if the total is r, then what will be this distance? R minus a. Similarly, if this is r and if this is a, the total distance is r plus a. Okay, I have just mapped the distance in between the charge and the point where we are going to find the electrostatic potential. Now with respect to plus q, come back to this 1 by 4 pi epsilon 0 q divided by the distance in between the point where we are finding and the charge, that is positive charge. What is that? R minus a. And now ignore this, potential in between these two will be 1 by 4 pi epsilon 0 q divided by, here it will be minus q because that is due to a negative charge, this is due to a positive charge. So 1 by 4 pi epsilon 0 minus q divided by, what is the distance in between them? R plus a. Now what is the net potential? Add both of them because these are scalar. V plus q plus V minus q is equal to, add both of them, 1 by 4 pi epsilon 0 q divided by r minus a plus 1 by 4 pi epsilon 0 minus q divided by r plus a. So I can take 1 by 4 pi epsilon 0 and q in common, this will be r minus a minus 1 by r plus a. Now q divided by 4 pi epsilon 0, simplify this, r plus a minus of r minus of minus a will be plus a divided by a minus p into a plus p, that is r square minus a square. See, r plus a will come this side, r minus a will come this side, and r minus a have to be multiplied with negative, so that will be minus r plus a. So r and r will cancel, plus r and minus r will cancel. We have a plus a 2a, that have to be multiplied with q, and that will be 2aq divided by 4 pi epsilon 0 r square minus a square. This is the potential due to a dipole on an on an axial plane. What is 2aq? 2aq is nothing but dipole moment. We have learned in the first chapter. So I am going to simplify 2aq as p dipole moment divided by 4 pi epsilon 0. Now when r is very large as compared to a, I can ignore a square. Okay, when a is small, when r is very high, when very large, a square can be neglected to 0. So this will be 4 pi epsilon 0 r square. This is potential due to dipole on an axial line. Just compare this equation with the previous equation you have learned in the case of electric field. What was electric field on an axial line? That is 2p divided by 4 pi epsilon 0 r cube. Now instead of 2p we are having p here, instead of r cube we are having r square, just one less. Here 2p, 1p. Here it is r square, r cube. So just compare and learn. Okay. Thank you.